Okay, today we're going to do the introduction to organic chemistry. We're going to start with the very basics and basically nomenclature. So basically we know that organic chemistry is basically the study of hydrocarbons and their reactivity. And their reactivity comes from the different substituents that you might find attached to carbon chains. So basically first what we're going to have is, I'll give you a basic carbon chain, which would be represented by, let's say, 2 carbons connected to each other, and then we would have hydrogens attached to it. So basically the naming of hydrocarbons, we're just going to be discussing first hydrocarbons, which is going to be just carbons and hydrogens. So the naming comes from the carbon backbone, and you count how many carbons there are. In this case, there are 2. So basically we could have a 1 carbon structure, a 2 carbon structure like I've drawn right there, a 3 carbon structure, and a 4 carbon structure, Now, obviously, this goes on and on to basically infinity. You can have as many carbons in a chain, up to, like I said, 20, 30 carbons in a chain. And again, the reason why carbon is so special and it's able to do this is because it has a valence of 4, meaning that it's very happy to make 4 bonds around it, as you can see here with the 3 hydrogens and the, connected to the other carbon, or, 2 carbons and 2 hydrogens, or just right here where it's connected to 4 hydrogens. So basically in the naming of these, what you want to remember for the first 4, because they have interesting names. After that, it's just really simple. But the first 4 are going to be methane, ethane, propane, and butane. So I like to remember meth, eth, pro-bu, meth, eth, pro-bu. So I just, if I'm trying to figure out the name of a hydrocarbon, I just go through that, counting how many there are. So the first one will be methane, because these are alkanes. So basically just the bare bones of organic chemistry, just plain carbon backbones, are going to be alkanes, and they consist of carbon and hydrogen. So that's why you see that the ending is ane, because they're all alkanes. So we have alkanes, and that's why they have the ending ane, like that. So, okay, so like I said, meth, eth, pro-bu. So the first one with just 1 carbon, that's going to be methane. If it has 2 carbons, it's going to be ethane. If it has 3 carbons, it's going to be propane. And if it has 4 carbons, it's going to be butane. And then basically after that, it's pretty simple. 5 pentane, 6 hexane, 7 carbons heptane, 8 carbons octane, 9 nonane, 10 decane, and so forth, depending on how many carbons you happen to have in that chain. So this way of drawing these alkanes can be kind of tedious, as you saw, drawing all these hydrogens. So we have other ways of being able to draw them that you might see that are pretty common ways of writing them. Like, for example, we have the condensed formula. So let me get a different color here. In condensed formula, you would just write out basically what you see, but without the bonds. So in this case, we're going to have CH4. In this case, it's going to be the CH3 and then CH3. So CH3, CH3. In this case, we have a CH3, and then we have a CH2 and another CH3. So this is going to be CH3, CH2, CH3. So basically, if somebody were to give you this, you'd be able to just say, oh, okay, I know that's going to be a CH3, and then that's connected to a CH2, and then that's connected to a CH3, kind of like in a line, like you see here. So, so that way you're not getting confused. And then same thing for here. We have CH3, CH2, CH2, CH3. CH3, CH2, CH2. Yeah, CH3, like that. So, so that's a much, faster way of writing it. However, the major point, I guess, of doing organic chemistry is to do synthesis with these molecules. And so when you're doing these reactions, it's kind of, it's kind of hard to see where the bonds are in this notation because you can't really see where things are connected. So you can't really draw out where the electrons are going. And then, of course, with this notation, it can get kind of tedious if you have to write, let's say, like a 10 carbon molecule, 20 times over for this reaction. It can get kind of tedious. So we have another way of drawing them, which can be, useful in that situation. And that's basically where it's called line structure. And it's basically where you draw lines, and each point in the line represents a carbon. So basically, methane doesn't really have a structure like that because there's only one carbon, so that one won't have it. But let's say for ethane will, and that's just going to be one line because there's two carbons, so it's going to be like this. It's going to be just one line. And you'll see, you've probably seen this, a lot, or remember seeing this. Propane, there's 3 carbons, so it's going to look like this. 1, 2, 3 carbons, like that. So basically there would be 1 carbon there, 1 there, and 1 there. So you would count the points. So you don't count the bar in the middle. That's kind of like the bond. So and then in butane, you're going to have 4 carbons, so it'll look like this. 1, 2, 3, 4. And then, of course, pentane would look like this. 1, 2, 3, 4, 5. That'll be pentane, and then that'll be hexane, 5, 6, and then 3, 4, 5, 6, 7, heptane. So, and so on and so forth. So, yeah, that's how you would do that.